Hello my friends. So this is a solution for KVPY examination for stream SA, and this examination was conducted on 5th of November 2017 and very useful when you are writing for the next year examination for KVPY. So let us see the solutions one by one. Question number 31. The structure of 3-methyl pentane 2-ene is, so this is the nomenclature. So you have to take this longest carbon, that is pentene 2,5. So pentene 2,5 means there is a 5 carbon. Pentene means 5 carbon, and 5 carbon, second carbon is having double bond. So from this we can see second carbon double bond is means A, B, C, 3 are options, and third carbon having the 3-methyl. So we can see, so this is the second carbon double bond, third carbon is methyl. So as per these questions, so if you see carefully, so this is the 5 carbon double bond and methyl. So our ANC is correct answer. The stability of carbanion is, so if you see carefully, 1, 2, 3, 4. So in this case, this is your primary carbocation. Okay, this is your secondary carbanion. This is the carbanion is there, secondary carbanion, and this is the tertiary carbanion. So all these are carbanion is there, and this is your resonance. So this carbanion is under resonance is there. So as per the stabilities, so if you compare it, so this will be more resonance stabilized. This will be your resonance stabilized. So this carbanion is resonance stabilized. So fourth is your, you can say this is your most stable anion. Now after that, in this case, if you see carefully, it is coming 1 because it's a primary carbanion. Because in secondary carbanion we have CH2, CH3, and this will act as your plus I effect. Means this will give electron to the carbon. So this carbanion is again most stabilized, destabilized. And 3 you can see there are 9 hydrogens are there. So again this will destabilize the this anion is heavily. So first is 1, and then followed by next is your 2, and then followed by 3. 3 is highly unstable. So as per the question, which of the options are correct? So if you see carefully, so answer is our C is correct answer. In the following reaction, so this is diazonium chloride is reacting with the phenol in presence of alkali. So what is the major product? So if you see carefully, this is an example of your coupling reactions with the diazo salt with the phenol. So when this will react, so we will get here. So this is your di. This is our di, and this is only correct answer for this question. In the reaction of 1-bromo-3 chlorocyclobutane with 2 equivalent of sodium and ether. So this is our cyclobutane, and this is your PR, and this is your Cl(1,3). Okay, and this is reacting with the, you can see sodium, ether is this is your dry ether, and we are taking sodium is 2 equivalent. So definitely first Br will be goes out because this is the big size, and after that this becomes a free radical, and then followed by Cl will be removed. So there will be 2 free radicals, one here, one here. So this will again this will attack on this one, so you will get this compound. So as per answer, our D is correct answer. The order of basicity. So basicity is actually is defined as the nitrogen. See, if you see carefully, all are nitrogen present. So we'll see which nitrogen has maximum lone pair is there. The lone pair existing in which type of nitrogen. So if you see carefully, this NO2 is at para position. So this is the very strong electron withdrawing group. So here you have minus R effect is there. So definitely the lone pair present of the nitrogen is, again it is not present over here. So density will decrease. And in this case you can see the lone pair. So this is your normally your you can see your primary amines is there, and here lone pair is maximum. In this case lone pair is there, but due to resonance maybe some amount of lone pair can be decreased due to resonance. And in this case the lone pair is, this is an example of pyrrole compound. Here lone pair is, again it is involved with the resonance. So here fully resonance is there, the resonance involved lone pair. So this is not available in nitrogen. So where lone pair is mostly present, it is just 2, and then after 2, in which case it is present, then 3, then 2, 3, and then you can say here 1, and last is 4. So if you see carefully, 2 is first, then followed by your 3, and then followed by your you can say 1, and then followed by 2. So this is resonance stabilized. So it is not 4. So as per this option, so this is correct. The first ionization energy of sodium, boron, nitrogen, oxygen atoms and follows the order. So to find the first ionization energy of these atoms, so let us write their electronic configuration. If you write sodium, so it will be your let us take last one 3s1. So electron is emitted released from the third s subset of f suborbital of third orbit. And if you take the boron, so it is your nothing but the boron having atomic number is 5, so it will be having 2p1. For nitrogen, it has 7 electrons, so 7th electron will be your 2p3, and oxygen is 2p4. Now in which case ionization energy will be very easy. So here ionization energy is very minimum, thus definitely sodium is last. And in case of nitrogen, it is where you will get the maximum energy because it is the half filled orbital. In case of half filled orbital, it is very difficult to take out the electrons. If you give electrons, it will give you the maximum amount of energies. So our options, if you see carefully, it is your coming sodium and nitrogen. This is coming. Now let us check for boron and oxygen. So in case of boron, it is 2p1. So as compared to this one oxygen, so as compared to oxygen, so it is very easy to remove out one electron from the boron rather from the oxygen, because it has only one electron. So if you see the order of its ionization energy, so first energy will be given maximum by the nitrogen, then oxygen, then boron, and then sodium. So as per this question, the answer will be B. So B is the correct answer. Among P2O5, AS2O3, Sb2O3 and Bi2O3, so which is the most acidic oxide? Now acidic oxide down the group, you can see this is the member of group 15, and if you take the down the group, acidic strength is decreasing. Acidic strength will decrease. It will decrease. Why it will decrease? Because size of atom is increasing. So when size of atom is increases, the acidic strength will for oxide will decrease. So among this one, so which has a maximum minimum size, so minimum size is P2O5, so this is more acidic as compared to Bi2O3. So also we can say that this is more electronegative. Again you can see that size also of phosphorus also very small, so due to acidic strength also increase as compared to arsenic, antimony and bismuth. So this is more acidic oxide, this will be your least acidic oxide. Among the potassium, magnesium, gold and copper, the one which is extracted by heating its ore in air. I mean, that is, they're asking which of the ores is normally roasted. And if you know, so normally the ores which is roasted, that ores are normally sulfide ores. So in these cases, which element is forming sulfide ores? So mostly copper is the example which is forming the sulfide ores. So sulfide ores means you have C2S, that is called as copper glance. So copper glass, if you roast it in presence of air, so this will give you Cu2n plus sulfur dioxide. Sulfur dioxide is emitted as a gas. So you will get here Q plus oxide. So answer is our D. Remaining, this is element. These two are mostly forming halide and oxide ores. So which is normally potassium undergo again you can say roasting, no, sorry, calcination. Here also go calcination. Only this will go your you can say here roasting. So that's why our answer is D. Now the metal ion with total number of electrons same as S2 minus, means they're asking isoelectronic configurations. So if you calculate, so sulfide, it has 18 electrons. Okay, so we have to see which element has 18 electrons. Sodium, so it will be 10 electrons. So no, wrong. This is calcium. Calcium is 20. So 20 minus 2, it is 18. So this answer could be correct, 18 electrons. For magnesium, magnesium has a 12, so 12, atomic number is 12. So 12 minus 2 is a positive, it becomes 10 electrons, so it is isoelectron to sodium. So again wrong, this is also wrong. Strontium, that definitely this is belong to fifth group. So fifth group is definitely it has more than, you can say 18 electrons. This option is again right, wrong. So only answer B is correct. X gram of calcium dissolves completely in concentrated acid solutions to produce 5.04 liters of hydrogen gas at STP. So what is the value of X is closest to? So we can use the concept of equivalent over here. So equivalent of, you can say calcium dissolving HCl, and they are giving the hydrogen. So we can say it is equal to HCl, equivalence of HCl, and again it is equal to equivalence of hydrogen, I guess. So equivalence of calcium is nothing but the weight of calcium. So we can say weight of calcium, that is X divided by equivalent mass of calcium, and this is equal to equivalence of hydrogen means you can take in terms of liter also, equivalent volume of hydrogen. We can say equivalent volume radii means weight of hydrogen, or you can say volume of hydrogen, and divide by equivalence volume of hydrogen. You can say it like this one. So if you solve it, so on solving, what is the weight of calcium? This is your x, and this is the weight of calcium is 40 and factor 40, so equivalence will be 20, and volume hydrogen is given 5.04, and equivalent volume of hydrogen is nothing but it is your 11.2. If you solve it, x will equal to your 4.5 multiplied by 2, that is 9. So answer C is correct. A 20-gram object is moving with the velocity of 100 meters per second. What is the de Broglie value of the object? So we can apply the formula lambda is equal to h by m into v. Substitute the value 6.626. It is given here 10 power minus 34. And what is mass? Mass is 20 gram. And what is the velocity? So velocity will be your, you can see here, mass is 20 gram is 20 power minus 3. And velocity is given 100 meters per second. If you solve it, on solving you will get here answer. So it will come about this answer is correct. If you solve it, you will get 3.3 into 10 power minus 34. Already I have calculated. So it will be in terms of, so they have not given, you will get in terms of meter. So A answer is our correct answer. 42. In a closed vessel of at STP, 50 liter of methane is ignited with 750 liter of air. Air containing 20% of oxygen. Now they are asking number of moles of oxygen remaining in the vessel on cooling to room temperature is closest to. So we know the equation. So 20% of oxygen means, if you calculate, so 75 into 20%. So how much oxygen is there? So oxygen will be equal to 20% of 750. So it will be your 150 liters of oxygen is there. Now methane is reacting with the oxygen. So if this react with the oxygen, you will get CO2 plus water. This is the gases, and if you cool it, so on cooling, what will happen? So water will be, again it becomes your liquid in states. So just balance this equation. So on balancing, there is a 4 oxygen hydrogen, so it will be 2, and oxygen will be 2 plus 2 4, so there is 2 oxygen. Means it is 1 mole. If you take in terms of mole, this is 1 mole, this will be 2 mole. So this is the mole wise. So we have to convert how many moles of methane is there. So moles of methane will be how much? So it is your 50. If you're taking 50 means you apply this one 50 by at STP is 50 into 22.4 liters. So this is the number of moles. So 50 by 22.4 liters, it will be about something 2.2321 something liter will be there. Okay, and similarly for moles of this one oxygen, so oxygen is 150 liters. So for oxygen moles will be how much? So 150 divided by 22.4 liters. So if you solve it, it is coming about how much? So this will come about 6.696 is there. So if you subtract, now you see for 1 mole we require 2 mole definitely. So if it is 1 mole, so definitely oxygen we require it double of this one. So it is somewhat something oxygen will be required. So required oxygen will be double of 2.23. So 2.234 into 2. So you will get here 4.468. Now subtract from here because this is the maximum. So if you subtract 6 point minus here 4.468, on subtracting you will get here 2.228. So this is 2.2. So if you see carefully, this answer is our correct answer. Carbon dioxide passed through lime water. So this lime water is calcium hydroxide, and if you passing carbon dioxide, so it becomes your calcium, we can say carbonate. So this becomes your milky in color. So this becomes milky in color, and it becomes again clear if you continue bubbling. So if you give here again, so this is calcium carbonate plus water. So in this again, if you give continuous carbon dioxide, so it will convert into calcium bicarbonate ion, and this is your soluble in water, and this solution becomes very clear solution. So answer is D. The maximum number of electrons that can be filled in a cell with a principal quantum number n equal to 3. 3 means 3s, you can say next is 3p and next is 3d. So how many electrons will be there? So it will be 2 electrons, here will be 6 electrons, here will be your 10 electrons. Total will be, if you count it, becomes your 18 electrons. Very easy questions. 18 answer. The atomic radii of lithium, fluorine, sodium and silicon will follow the orders. So if you see the radii, atomic radii as see experimentally you cannot find, it is very not easy to find the atomic radii of the element, because we don't know the exact boundary. So we can, you have studied van der Waals radii, ionic radii, but atomic radii is not possible for single atoms yet. Let us see. So which is the greatest? So as per some theoretical, you can say, so sodium, if you take lithium is your small b, and fluorine is again same category. So it has 2 subcell, again it has 2 subcell, while for sodium with 3 subcell and silicon 3 subcells. No, so cells are there. Energy cell of sodium is 3 and energy cell of silicon will be 3. So 3 means we have K, L and M. So definitely sodium has only 1 electron, means 11 electron is there. So it will be 3s1. For silicon it will be 3s2 3p4, you can say that. So it has the more number of protons, so definitely sodium will be your highest, and which is the lowest. So out of these 4, so we can see the fluorine will be lowest. So this is the highest, bigger cell, and this is the lowest cell. Now in between 2 left, one is your lithium, second is silicon. Now as per if you see the rule, there is no option is given, because if you see it has 3 subcell, it has 2 subcell, sorry, 3 energy cell is there, and lithium has 2 energy cell is there. So after sodium there is chance of coming first is silicon, then lithium, then fluorine. So if you see like this, is first is your silicon and then is your lithium. So in this there is no option is present. So this is ruled out, this is ruled out, but C and D left. So we cannot take the radii. This is belong to group 2, sorry, group 1, and this is your group 14. This is group 14 and this is your group 1. So it is very difficult to tell the radii by seeing the atomic size. So we cannot determine by just by seeing like it has 3 is there, it has 2 energy cells there. So there may possibility of lithium can be greater than that of silicon. It may possibilities. So apart from this one, C, out of C and D, so this is the most probable answers. C cannot be possible answers. So in 45, answer D is only correct answers. Remaining is wrong. This is the second part of the KVPY. The reaction of the alkene X with bromine produce a compound Y, and this Y has 3 elements is given. They have given carbon, hydrogen, bromine. And if you next is if you ozonize this alkene X, you will get only one product. So first we have to find what is Y actually. So this is the some percentage given. So by using the empirical formula, we can get empirical formula first. So for carbon, what is the percentage? So carbon is 22.22, and you just divide by 12. On dividing by 12, you will get the value 1.8516. This is the already I have calculated. Similarly for hydrogen, it will be your how much? So it is 3.71, and molar mass is 1. So again it will be 3.71. And for oxygen, sorry, for Br, so it will be your 74.07, and again divide by 80, molar mass is given. If you solve it on solving, you will get 0.9258. Now this is the list. So if you divide by same numbers, you will get 1. Again by divide by 0.92, so you will get here approximately 4. But if you divide by same 0.92, so you will get here the number of moles will be 2. This means that empirical formula for this carbon, hydrogen, bromine is C2H4 and Br. Okay, so this is not possible empirical formula. So we have to take the nearest alkene, and you have to see the option. So C2H4, so if you make it double, so it becomes your C4H8 Br2. So this is something coming your bromide is there, 2 bromide is there, and maximum is C4. So C4 means so definitely butene is not possible, only 2 butene is possible, because you have to see one option. If you do the ozonolysis of alkene, we will get one product. So definitely if you take this butene double bond, and if you keep this Br2, so we will get the compound here, 1 Br this side and 1 Br this side is there. So definitely if you do ozonolysis here, so you will get here so 1 ozone and second 2 molecules of you can say ethanol. So definitely our C is correct answer. In the following reaction, this is CS3 CaCS, so this is your something propine is there, and this is oxymercuration is there. You can see here mercuration, and followed by X compound, and then again dilute sodium hydroxide in presence of phenol formaldehyde. So from here, if you see this addition of water will take place over here. So you can see like CH3 and C triple bond CH. So if you add water in presence of this acid and mercury as a catalyst, so OH is added this side, hydrogen added, so it will form your CH3COH, and this will be your COH, and this will be double bond with CH2, and this will again tautomerize. So on tautomerization, so what will happen? This will again convert into CH3, CO and CH3. So this is your acetone. Now acetone is a carbonyl compound, and this is reacting in presence of PH and CHO. And we have next reaction is sodium hydroxide in dilute solution. So that means this is your aldol condensation. So aldol condensation, this will act as an anion. This anion will attack in this carbon. Okay, so you will get next compound. This is your phenyl, and phenyl carbon attacked by CH2. So it will be CH2, CO and CH3, because base will abstract proton from this any alpha hydrogen. So you will get here oxygen and here hydrogen. So again this will be protonated from water. So you will get OH. So next compounds of phenyl, and this is your CH, again OH, and this is your CH2 and CO and CH3. CH3 is there. Again, if you heat it, so dehydration will take place. So in this compound, this becomes alpha beta unsaturated compound. Yes, this becomes CH double bond with CH and COO and CH3. So if you see, compare it, which answer is correct. So X is acetone, definitely B and C is there. So after B and C, this compound is only we are getting in. This is Y is there. So this answer is correct. KMnO4 react with the H2O2 in acidic medium. So number of moles of oxygen produced per mole of KMnO4 is. So right here KMnO4, and it is reacting with H2O2 in acidic medium, which can be sulfuric acid. And on reaction, the Mn will convert it to Mn2 plus, and again we get the potassium also here. So potassium is no use, and H2O2 will convert, it will give you oxygen, and next is water. Now if you compare it here, oxygen state is 5, in this oxygen state is given 2. So if you compare it, the change of oxygen number will be 5 minus 2, it will be your 3. So this will be not 5, it will be 7. So 7 minus 2, it will be your 5, changing oxygen number. And for H2O2, this is oxygen number is 1 for per oxygen, and this will be 0. So if you see carefully, this is undergoing reduction, and this is oxidation. So minus 1 for 1 oxygen, for 2 oxygen it will be 2. So now you make it equal the change in oxygen number. So it will be 2 into 5, and this is 5 into 2. 2 means you have to multiply it by 2, here 2, and 5 is multiplied by here 5, multiplied by 5. So now we got the moles. They are asking how many moles of oxygen produced per mole. Per mole is for one molecule. So for 2 molecules, we are getting 5 moles of oxygen. So if you take 1 molecule of KMnO4, so it will be 5 by 2, means it will be 2.5 moles of oxygen. So our answer is A, correct. The photoelectric behavior of potassium, lithium, magnesium and silver metals, it is shown in a plot. In this you can see this plot. If light of wavelength 4 nanometer is incident, then which of this metal will emit photoelectrons? Means photoelectrons will be emitted if the threshold frequency will be more than that of the minimum threshold frequency will be more than that of these metals. Okay, so we have to find what is the threshold frequency for this one. So if you see here carefully, so threshold frequency of every metal is given here. K is something, this is 2.5, means it will be less than 2.5 for potassium and lithium. For magnesium it is something more than 3.5, and for silver it is given this one. So already threshold frequency is given over here. This is the photon energy, and this is the frequency. So first we have to find your energy, that is what is the threshold energy. So we can write E, that is we can see H naught is the threshold frequency, this energy, threshold energy is there. So if this is energy will be threshold energy. So E into H into U mu naught. So we can write here Hc by lambda. What is H? So H is your 6.626 into 10 power minus 34, and C is 3 into 10 power 8, and lambda is given 400 into 10 to the power minus 9 nanometers is given. So this will give you the threshold energy, this one. So if threshold energy is there, so if you solve it, on solving you will get something, and again you have to multiply it by electron volt, because answer is given in terms of, this is the electron voltage, so you have to multiply it by 1.6 into 10 to the power minus 19 also. So this whole will convert to electron volt energy. So if you see carefully this one, so you will get answer 3.1 electron volt. Now this is our threshold energy, this one 3.1 electron volt threshold energy. So incident energy is our 3.1 electron volt. Now threshold energy for lithium is again less than 3.1 volt, and for potassium is again, so it is less than 3 volt. So if you get this much amount of energy, so what will happen? Magnesium Ag, it has more than 3.5. So definitely they will not give electrons. Only lithium and potassium will be able to give electrons, because you are providing energy like a more incident radiation than their minimum threshold values. So out of 4 options, only potassium and lithium can give photoelectrons, while magnesium, Ag, all this will not give your photoelectrons. A piece of metal weighing 100 gram is heated to 80 degrees centigrade, and it is dropped into 1 kilogram of cold water in an insulated container at 15 degrees centigrade. If the final temperature of the water in the container is 15.69 degrees centigrade, what is the specific heat of the metal in joule gram per degree centigrade? So we'll apply simple formula is there. So heat lost by metal is equal to heat gained by water. We can say water is very cold water, heat gained by cold water, we can say like this one, by cold water. So this is very simple questions. So we'll use the formula of like mc theta. So mass of the metal is how much? It is given 100, and specific heat of metal we don't know, and theta will be your maximum temperature. Heat loss is there, so we can write it 80 minus theta. Theta is your final temperature, so we can write here 15.69 degrees centigrade. And again heat gained by water. So what is the mass of the water? Mass of the water is given here. So 1000 kilogram is, you can see the 1000, and the specific heat of water is 4.2, and multiplied by temperature is the last temperature is 15 point, final temperature is 69, and divided by the common temperature, that temperature of the water. If you solve it, so on solving you will get Cm is equal to 6.9, and divide by 64.31, and multiplied by 4.2. On solving you will get a 0.45. So on seeing the answers, so this answer is correct answer. So that is the end of our this KVPY papers. Thank you very much.